For this experiment, you will need a linear track that is level, a shop vac connected up to it to make it virtually frictionless, a glider, photo gate, and on the glider a 12-section picket fence, a string, an assortment of masses, and an interface that will measure the times from the photo gate. Here is the interface in this experiment. We're using a lab probe and a calculator connected up to it to record the times and arrive at the accelerations. Here's the 12-section picket fence. You can see the distance between the beginning of a black section and the next adjacent black section is 1 centimeter. The calculator is going to use this to determine the velocities and therefore the accelerations. For trial 1 in part A of the experiment, you take a 20-gram mass and place it on the end of the string. Now this is the program running on the calculator that will be recording the times from the lab probe, and it'll use the distance and the time to calculate the speeds and do a speed time graph, and the slope of the speed time graph is the acceleration, which is what we want in this experiment. Here we'll be using a lab probe, and here we choose number 4, which will give us a speed time graph, and the slope of the speed time graph is the acceleration. The program needs to know how many sections the picket fence has, and the one we're using has 12, and the distance between the sections on the picket fence are all 1 centimeter apart. So here's the speed time graph for the very first trial with 0.2 newtons of force, and you can see the acceleration at the bottom is 0.395 meters per second squared. Copy this down in your data table for trial 1. Now, once you've copied that down, you can repeat the experiment with a different force. Now, for trial 2, you take one 20-gram mass off the glider and place it on the string with the other 20-gram mass for a total of 0.4 newtons of force. Now, with 0.4 newtons of force on the system, we can record the acceleration of the glider for that force. And at the bottom here, you'll see the acceleration for the 0.4 newtons of force is 0.796 meters per second squared, which is the slope of the line on this speed time graph. For trial 3, take another 20-gram mass off the glider and place it on the string for a total of 0.6 newtons of force acting on the system. And as you can see at the bottom here, slope of the line on the speed time graph, which is the acceleration, is 1.171 meters per second squared. Record this in your data table. And you can record this acceleration. You can see at the bottom, which is the slope of the line on this graph, 3.162 meters per second squared. In part B of the experiment, we are going to keep the force constant. This is going to be done by hanging a 50-gram mass on the string and keeping that same mass on the string throughout the experiment. Now, the mass of the system initially is 381 grams. So for part B, a 50-gram mass is placed on the string and kept there throughout the experiment. Now for trial 1 of the experiment, we have the 50-gram mass hanging on the string and the glider. No masses on the glider. And here's the rate of acceleration, 1.262 meters per second squared, which is the slope of this line on the speed time graph. For trial 2 of this experiment, we take a 50-gram mass and hang it on the glider and measure the rate of acceleration of the system now with the increased mass. So for trial 2, the acceleration is 1.105 meters per second squared. Now for trial 3, we add another 50-gram mass to the glider, keeping the force the same and measuring its rate of acceleration now. And you can see the rate of acceleration here is 0.620 meters per second squared. Now with the data for Part B and Part A and the sheet that comes with this video, you can analyze the data and answer the question for the lab.